Hi, today we're looking at section 7-2, powers of 10 and scientific notation. Again, take something out to write on and take notes. You can pause the video at any time to write your notes or go back and review one of the prior concepts and complete the check it out problems after you do the examples on your worksheet. Our learning targets today, I can evaluate and multiply by powers of 10, and I can convert between standard form and scientific notation. So you should have had scientific notation already in your science classes. So hopefully this will be a nice review. So powers of 10. When we have a positive integer exponent, so we looked at exponents in our last section, our last unit. So if n is positive integer, find the value of 10 to the n by starting with 1 and moving the decimal point n places to the right. So 10 to the fourth, n's positive, so we're going to have a bigger number. We'd start here and move it 1, 2, 3, 4. So it ends up to be 10,000. So again, positive integer is going to make a larger number. A negative integer exponent, if n is a positive integer, find the value of 10 to the negative n by starting with 1 and moving the decimal point n places to the left. So we'd start here, and these are powers of 10. So we move 1, 2, 3, 4, 5, 6. And again, notice it's a negative exponent. It's a much smaller number because it'd be 1 over 10 to the 6th. Again, this is a review from what we did in the 7-1 lesson with our exponents. So let's look at, and these are just powers of 10. So complete the table. 10 cubed is going to be 10 times 10 times 10, or 1,000. 10 squared is 100. 10 to the first is just 10. 10 to the 0, remember, to the 0 exponent is a 1. 10 to the negative 1 is going to be smaller, or if we're doing decimals, 0.1. This would be the same as 1 over 10 squared, or 0.01. 1 over 10 cubed, which would be 0.001, and 1 over 10 to the fourth would be 0.0001. You start here, move it 1, 2, 3, 4. You can also look at it and do, we have 4 zeros, 3 to the right of the decimal, and make sure. So powers of 10. So our first example, we want to find the value of each power of 10. So we have a negative exponent here, so it becomes 1 over 10 to the 6th, or 0.12345 1. So we start here, 1, 2, 3, 4, 5, 6. The decimal goes there. 1 or 10 to the fourth would be 1 and then 1, 4 zeros. So we'd start at 1, move 1, 2, 3, 4. Decimal end up here. 10 to the ninth is going to be a 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So putting our commas in there. We'd start here, 1, 2, 3, 4, 5, 6, 7, 8, and decimal would end up right there. So you can always go back and make sure, is your decimal in the right place? Here are some check it outs. And remember, reading math, if you do not see a decimal point in a number, it is understood to be at the end of the number. So if we had, for example, if we have 2, that's actually 2.0, and zeros continue on. Decimal is always going to be to the left of that number, or the end of it. Now we want to go the other direction, right as a power of 10. So this is going to be 10. This is much larger than 10. It's going to have a positive exponent. So it would be 1, 2, 3, 4, 5, 6, 10 to the 6th. This is going to be 10 to a negative exponent, 1, 2, 3 to the negative 4th. This is going to be a positive because it's much larger than 10. And we have 1, 2, 3, so it would be 10 cubed. Okay, so now you have some check it outs. Again, write them as a power of 10. This is a positive exponent, a negative exponent, and a negative exponent because those are less than 10. Now multiplying by powers of 10. If the exponent is positive, the number is going to be much larger. So 125 times 10 to the 5th, it's going to be a much larger number. The exponent's negative, we have 10 to the negative 3, the number will be smaller. So keep that in mind. So here we want to multiply by powers of 10 each of those expressions. So for the first example, we have 23.89. So we move the decimal 8 places to the right, making it larger. So 23, 8, 9. So we went 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Decimal ends up here. So we're going to end up with the number 2, 3, 8, 9, 1, 2, 3, 2, 3. So it's a very large number. For the next one, this is going to be smaller. So we'd have 467. Moving it this way, it's going to be 0.467. It's a smaller number there. Move the decimal 3 places to the left. And yes, now it's your turn. Larger number, positive exponent. A negative number is going to be a smaller number there. It's going to get even smaller. Scientific notation. This should be a review from your science classes. And scientific notation is a method of writing either numbers that are very large or very small, and it's going to allow you to do operations with it. And has two parts to it. The first part is a number that has to be greater than or equal to 1, but less than 10. And the second part is going to be your power of 10. So 3.5 is greater than 1, greater than or equal to 1, but less than 10, and 9.98 is greater than 1, greater than or equal to 1, but less than 10. So those are the parts of the scientific notation. So in this example, we have Saturn has a diameter of 1.2 times 10 to the 5th kilometers. It's a distance from the sun. Distance from the sun is about 1,427,000,000 kilometers. Write Saturn's diameter in standard form. In standard form refers to the usual way that numbers are written, not in scientific notation. So the first we want to write Saturn's diameter in standard form. And standard form is how you usually see your numbers, not scientific notation. So we are told that Saturn's diameter is 1.2 times 10 to the 5th kilometers. So in standard form, we would move the decimal 1, 2, 3, 4, 5, so it becomes 120,000 kilometers. So this would be standard form, going from scientific notation into numbers we generally work with. For the second example, we want to write Saturn's distance from the sun in scientific notation. So Saturn's distance, this is the distance here. So scientific notation, our first part of scientific notation has to be a number greater than or equal to 1 but less than 10. And we have to keep all the significant digits here. So it's going to be 1.427. So the decimal goes here, and we have to move it to where our decimal is here. We have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 to end up here. So it's going to be 1.427 times 10 to the 9th kilometers. And again, scientific notation has to have this first part and then times, which is we use the X symbol for multiplication in this case, a power of 10. It has to have all those components with it. Here's your check it out. Write Jupiter's diameter in scientific notation, and then write Jupiter's orbital speed in standard form. So here we want to compare or order the list of numbers from least to greatest. So in doing these, we want to look at both the front part, number in front, and then the exponents. So looking at this, we know that 4.1 times 10 to the 6th, these two have the greatest power of 10, but 4.1 is larger than 2.1, so that's going to be the biggest, followed by this one. Then we have that's going to go up there. Our next one, this is going to be the smallest, and then 1 times 10 to the negative 2, or 1.3. Let's take a look and see if that's... So it looks like this is going, these numbers are getting larger as we're going down, and in fact they are, so that's how they would be ordered. Now it's your turn to order them from least to greatest. Again, so look at the positive exponents are going to be larger than the negative ones. Then you have to, if the exponents are the same, look at the numbers out in front. So to summarize, multiplying by a positive power of 10, you're moving the decimal to the right, or the number is getting larger. Think of it that way. By a negative power of 10, your number is smaller than what you started with. In scientific notation, it's written in two parts. If we had x times, and you have to have that x there, 10 to some power where x has to be greater than or equal to 1 but less than 10. So that's where scientific notation has to fall between those. And this would be written, but you need this x, and there it has to be written that way. So good luck bringing any questions you have to class. Thanks.